Chapter 1.4.2.7 CronJob. Kubernetes v1.21 introduces the stable feature of cron jobs, which creates jobs on a recurring schedule for tasks like backups and report generation. Each cron job object resembles a line in a Unix crontab file and runs a specific job at regular intervals based on a cron schedule. However, cron jobs have limitations, such as the potential for a single cron job to create multiple simultaneous jobs in certain scenarios. The name of a cron job must adhere to DNS subdomain rules, which may lead to unexpected pod hostname results. To ensure compatibility, the name should follow stricter DNS label rules and be no more than 52 characters long, as the cron job controller automatically appends 11 characters to the provided name, with the constraint that a job name cannot exceed 63 characters. Example: the provided cron job manifest in the application job cronjob.yaml file prints the current time and a hello message every minute. For a more detailed explanation, refer to the guide on running automated tasks with a cron job. Writing a cron job spec. The text explains the syntax and features of cron jobs in Kubernetes. The .spec.schedule field is required and follows the cron syntax, allowing for advanced scheduling options such as steps and macros like @monthly. Web tools like crontab.guru can be used to generate cron job schedule expressions. The .spec.job template field defines a template for jobs created by the cron job, allowing for common metadata like labels and annotations. The optional spec.starting deadline seconds field sets a deadline for starting jobs if they miss their scheduled time, with missed jobs treated as failures. The spec.concurrency policy field specifies how concurrent executions are handled, with options to allow, forbid, or replace concurrent runs. It only applies to jobs created by the same cron job. The optional spec.suspend field can suspend job executions for a cron job, with suspended executions counting as missed jobs. The .spec.successful jobs history limit and .spec failed jobs history limit fields determine how many completed and failed jobs should be kept, with options to set limits or clean up jobs automatically. Time zones can be specified for cron jobs using the .spec.timezone field, allowing for schedules to be interpreted relative to a specific time zone. The Kubernetes v1.27 release includes a time zone database in the binaries as a fallback. Overall, cron jobs in Kubernetes offer a flexible and powerful way to schedule and manage jobs, with options for advanced scheduling, job templates, concurrency handling, schedule suspension, job history limits, and time zone specification. These features allow for efficient job management and scheduling within Kubernetes clusters, enhancing automation and scalability in cloud-native applications. Cron job limitations. The text discusses the unsupported time zone specification using cron TZ or TZ variables inside spec.schedule in Kubernetes. It states that setting a schedule with time zone specifications will result in a validation error starting from Kubernetes 1.29, and updates to cron jobs using TZ or cron TZ will issue a warning to the client. Furthermore, the text explains that modifying an existing cron job will only apply changes to new jobs created after the modification. Existing jobs and their pods will continue to run without changes. A cron job creates a job object approximately once per execution time of its schedule, but due to certain circumstances, 2 jobs may be created or none created. It emphasizes that jobs should be idempotent to avoid issues. The text then cautions about setting the starting deadline seconds field, as values less than 10 seconds may result in the cron job not being scheduled due to the controller's 10-second check interval. It explains how missed schedules are counted by the controller, especially when the starting deadline seconds field is set. The example provided illustrates scenarios where a cron job controller being down affects the scheduling of jobs, highlighting the importance of setting appropriate values for starting deadline seconds and concurrency policy. In conclusion, the text emphasizes the responsibility of a cron job in creating jobs that match its schedule, while the job manages the pods it represents. It provides insights into the intricacies of cron job scheduling and the considerations that need to be taken into account when working with cron jobs in Kubernetes.